Okay, so you little smarties are whipping through this stuff. So make sure that you are being very careful and you are holding yourself accountable to understanding it. I'm feeling a quiz coming on, so we will finish this section today, 12:4, and then we will move on. Let's see, I'll see you, let's see, this is Friday, so I will see you, no, this is not Friday, this is Thursday. So I'll see you Monday. This is what you're doing Monday. Wednesday we'll do some review, and then Friday you will take your quiz, 12:1 to 12:4. Okay, so here we go. We are binomials with radicals is the section. And we're gonna go back and do some old school FOIL method. Do you remember the FOIL method? That was just an acronym to help us keep track of our terms. It's not actually something you do. It's not like, it's a verb, but it's an acronym that helps us. So let's take a look at a binomial with radicals. So let's do square root of 15 plus the square root of 3. So that's a binomial, right? Two terms. And then we're going to multiply it by another binomial. So 4 square root 15 minus square root 3. Okay. So here's what we've got. If you need help, FOIL was our acronym. I don't typically use it, but you can if you like, if that helps you out. So here we go. Square root of 15 times 4 square root of 15 will be 4 times just 15, right? Square root of 15 times square root of 15 is just 15. All right, let's do the outers. So square root of 15 times square root of 3, well, and it's a positive times a negative, so it's going to be a negative. And then 15 and 3 is 45, so that'll be square root 45. We'll simplify later. Don't worry, those of you that get excited about that. Just give me a minute. Okay, positive times positive, so that's positive. Square root of 3 times 4 square root of 15, so that's going to be 4 square roots of 45. And then the last ones, it's a positive times a negative, so it's negative, and square root of 3 times square root of 3 is just 3. Okay, here we go. 4 times 15 is, let's see, that's a 260. I think I did it right. That's a 60. Combine like terms here, so that'll be a positive 3 square root 45 minus 3. I know there's more simplifying we can do, so let's do it. Let's combine these like terms here. 60 and negative 3, so that'll be a 57. Plus, and then 45, if we break it down, I know there's a perfect square in there, right? If we put a 5, we get a 9, so that's 3 and 3, so I have 3 square root of 5. 3 square root of 5 for 45. And we already have that 3 out front, so 3 and 3 is 9 square root of 5. All right, and it looks like, oh, can we combine these guys? No, remember you can only combine like radicals when you're adding and subtracting. So this is the multiplication. We just multiplied radical binomials. All right, so let's do another one, just for kicks. Let's do the square root of 13 plus the square root of 7 times the square root of 13 minus the square root of 7. Okay, why don't you go ahead and work ahead of me if you can. So do your FOIL. If you're still feeling shaky, you can follow along, but I highly recommend you go ahead of me and work this out and then check yourself. Like, don't look up until you're done and check and see how you did. I'll go step by step with mine. But I'm doing it quietly so that I don't mess you up. But quiet is sometimes uncomfortable. Today we had a leak in our wall. And so the plumber is here right now, and he has so far drilled, I think, 1, 2, 3, 4, 5 holes in my house. So that makes for a bit of an adventure. Okay, so there we go.
Bedroom's a mess.
Yes, your bedroom is a mess, Thomas, but that's nothing new.
No, there's nothing in it.
All right, so if you have finished, look up and check your work. So we've got square root 13 is 13, square root 13 and square root 7, negative square root 91, positive square root 91, and then negative 7. So wasn't this nice, guys? They just go bye-bye. And so you had 13 minus 7 is 6. That is super cool. Let's do another one. Let's do, let's see. Let's do the square root of 7. 7's nice. Plus the square root of 2 times the square root of 7 minus the square root of 2. Give that one a try. I want you to go ahead of me this time. If you didn't last time, I want you to go ahead of me this time. And then I'm going to work. And then you can check yourself when you are finished. Okay. Well, isn't this interesting? Look at that. This happened again. Why do you think this keeps happening? It's nice when it happens because we get some nice integer values. Why do you think this is happening? We've got the negative and the positive, or the positive and the negative. Actually, I should go negative, positive on that one. Negative, positive, there we go. But why does this keep happening? I feel like I'm going to break out into Moana right now. Okay, so notice, look at the problems. We have square root 7 plus square root 2, square root 7 minus square root 2. This one was square root 13 plus square root 7. This one was square root 13 minus square root 7. So we're noticing a sign situation here, right? All right, so there's actually a name for this. It goes by the conjugate. So let me write this down for you. When you have the square root of x plus the square root of y times the square root of x minus the square root of y. Those are called binomial, conjugate radical binomials. There we go. That's the fancy word. Conjugate. Conjugate. That just means opposite operation here between the terms. So conjugate radical. Well, that comes from the fact that we have radicals in here. And then binomials. Well, that's because we're multiplying binomials. So conjugate means what? Opposite operation. There's not two P's in operation, by the way. Don't even try. Okay, so conjugate means opposite operation here. If this is addition, the opposite of subtraction. If this was subtraction, the opposite would be addition. We're not going to do this with multiplication or division because we don't do that FOIL method when we are multiplying. Okay, so when you are multiplying conjugate radical binomials, it turns out super duper nice. It means that we're going to get x minus y in the end. Okay. So if I have something like the square root of 8 minus the square root of 3 times the square root of 8 plus the square root of 3, I can do it really quick now, knowing that these are, conjugate radical binomials. So I can say, hey, this is going to be 8 minus 3 or 5. Wow, that saves us so much time. Well, not only does it save us time, it also helps us simplify certain problems. So if I have something like 35 divided by the square root of 8 minus the square root of 3, and I'm asked to simplify this guy or write it in simple, right? In simple radical form. If that was my instruction, was to write in simple radical form. Remember simple radical form, the first little test that we look at is, hey, does it have radical in the denominator? Heck yeah, this has 2. This is like an uber violation. But remember last section, in order to get around that, we multiply by 1, but it's a 1 that we get to choose what it looks like. So knowing that this situation occurs when we multiply conjugate radical binomials, let's multiply this, make our 1 be the conjugate of the denominator. So let's multiply this guy by square root of 8 plus the square root of 3. Doesn't that make for the denominator into something super nice, right? 8 minus 3, the denominator becomes 5. And then the numerator becomes 35 times the quantity square root 8 plus square root 3. Hey, oh, look at that. Boom, so this is actually 7 times the quantity square root 8 plus square root 3. You can distribute the 7 if you want. Doesn't matter to me. Should we do another one? Let's do another one like that. Those are kind of fun. All right, another way of saying it is, rather than simple radical form, they might say rationalize. That's a fancy word. Rationalize the denominator. And simplify. Rationalize the denominator. Throw that one out at dinner tonight. See what people think. I learned how to rationalize the denominator today, people. Yep, I used the conjugate radical binomials to do that. Okay, so here we go. Here's our problem. Square root 3 minus 2 square root 5 divided by square root 5 minus square root 3. So, is it in simple radical form? Nope, we have our violation right here. So we're gonna multiply by 1. This 1 will be the conjugate. So square root, if you're going ahead of me, please do so, and then just look up and check. And so this turns the denominator into, right, 5 minus 3, right? Remember, we just do the x minus y business. All right, so the denominator is going to be a 2. And our numerator, okay, our numerator we're going to have to do a little FOIL, right? So that's going to be a square root 15 plus, oh, that'll be a 3, that's nice, minus, oh, that's a 5, minus 10, that's kind of nice, and then minus 2 square root 15. All right, and then we'll combine like terms. So I've got a negative 7 minus square root 15 all over 2. If you want to factor out the negative 1, that's a very sophisticated thing to do. And there you go. The 2 does not reduce in the denominator. And that's how it works. All right, I'll see you in Zoom.